Ever wonder where black holes come from, how they're born? The birth of a black hole is a cosmic event of grand proportions. Let's begin with a star, a celestial body that's approximately 20 times more massive than our sun. This star shines brightly, fusing hydrogen into helium in its core, releasing energy that lights up the cosmos. But as with all things, its life isn't everlasting. At some point the star exhausts its nuclear fuel. Unable to support its own weight, the core collapses under the force of gravity. Yet the outer layers of the star have a different fate. They're violently expelled into space, resulting in a supernova explosion. This stellar spectacle outshines entire galaxies, albeit briefly. But what happens next? What remains after the supernova's brilliant light fades? The core, now collapsed to a point of near infinite density, becomes a black hole. Despite its name, a black hole isn't empty space. It's a great amount of matter packed into a very small area, creating a gravitational field so strong that nothing, not even light, can escape it. These cosmic beasts lurk in the dark corners of the universe, unseen, yet betraying their presence through their gravitational influence on surrounding matter. They are the ultimate end state of stars much more massive than our sun, a final testament to a star's once brilliant life. The birth of a black hole, from a star's death to a supernova explosion, is a journey through some of the most extreme conditions in the universe. It's a tale of cosmic life and death, a testament to the incredible forces at work in the cosmos. Now that you know how a black hole is born, have you ever wondered what would happen if you fell into one? Stay tuned as we delve into the mysteries of black holes and their insatiable hunger for matter. So, what would happen if you fell into a black hole? Well, let's journey together into the heart of one of the universe's most fascinating and fearsome phenomena. Imagine, if you will, that you're floating in space, and you begin to feel an irresistible pull. You're being drawn into a black hole. As you get closer, you'd start to feel the effects of what scientists call spaghettification. Yes, you heard it right. It's as if the universe has a sense of humor. Named after everyone's favorite Italian dish, spaghettification is a process where the intense gravitational pull of the black hole stretches an object vertically while compressing it horizontally. So, picture yourself turning into a long, thin strand of spaghetti as you're stretched and ripped apart. This elongation happens because the gravitational pull at your feet is much stronger than at your head, creating a powerful tidal force. But before you're turned into cosmic pasta, you'd cross a boundary known as the event horizon. This is the point of no return. Once you cross the event horizon, there's no coming back. It's like the ultimate Roach Motel. Everything checks in, but nothing checks out. The event horizon is the threshold around the black hole where the escape velocity surpasses the speed of light. And since nothing can travel faster than light, not even light itself can escape a black hole's clutches once it's crossed this boundary. From the outside, an observer would see you slow down as you approach the event horizon, until you appear to almost freeze in place, due to an effect called gravitational time dilation. But from your perspective, you just keep falling until, well, you're spaghettified, so it's safe to say, a trip into a black hole would be a one-way ticket and quite the extreme experience. Well, that's a terrifying thought, isn't it? But what about the stars, the very things that birth black holes? How do they come to be? How are stars, those twinkling lights in the night sky, born? This question has intrigued humanity for centuries. Today, we have a clearer understanding of this celestial phenomenon. It all begins with a nebula, a vast and beautiful cloud of dust and gas floating in the cosmos. These nebulae are the star nurseries of the universe, where the birth of a star unfolds. In the heart of a nebula, gravity pulls dust and gas together. Over time, these particles become denser, forming a clump. This is the first step in the birth of a star, the creation of what we call a protostar. But a protostar is not quite a star yet. It's much like a caterpillar in a cocoon, going through a transformation. The protostar continues to grow, accumulating more and more mass from the surrounding nebula. As it grows, the pressure and temperature at its core rise dramatically. This is where the magic happens. When the core's temperature reaches a staggering 10 million degrees, nuclear fusion begins. Hydrogen atoms in the core collide and fuse together, creating helium. This process releases an immense amount of energy, causing the protostar to shine brightly. At this point, the protostar has finally transformed into a main sequence star, a fully fledged star like our own sun. It's no longer a caterpillar but a butterfly, radiating light and warmth into the cosmos. The star will remain in this main sequence stage, burning hydrogen and radiating energy for a long, long time. For a star like our sun, this stage can last for about 10 billion years. The birth of a star from a nebula to a main sequence star is a fascinating process. It's a cosmic ballet, choreographed by the laws of physics played out over millions of years. Stars have a fascinating birth, but did you know they also have different types? Did you know not all stars are the same? Yes, you heard that right. Each star in the night sky is a unique cosmic entity with its own set of characteristics. Some are tiny and relatively cool, while others are incredibly massive and scorchingly hot. Let's dive into this celestial diversity. Firstly, we have our familiar main sequence stars, like our very own sun. These stars are in the prime of their life, fusing hydrogen into helium in their cores. They make up about 90% of the stars in the universe, and their size, temperature, and brightness can vary greatly. Then we have the red giants. These stars are nearing the end of their life, having exhausted their hydrogen fuel. They're called giants for a reason. They're enormous. Some can be over 200 times the size of the sun. When a main sequence star runs out of hydrogen, it starts fusing helium and other heavier elements, causing the star to expand and cool, hence their red color. Now, let's shrink things down with white dwarfs. These are the remnants of stars like our sun after they've exhausted their nuclear fuel and shed their outer layers. They're incredibly dense, packing a mass similar to the sun's into a volume about the same as Earth's. They're also hot. Their surfaces can reach temperatures of over 100,000 degrees. Then, there are the neutron stars. These are the ultra-dense cores left behind after a massive star explodes in a supernova. They are incredibly small, about 15 miles in diameter, but they weigh more than the sun. Talk about a heavyweight in a featherweight's body. Lastly, let's not forget the hypergiants, some of the biggest and brightest stars in the universe. These stellar behemoths can be over 1,000 times the size of the sun, and their luminosity can be millions of times greater. Stars are as diverse as life on Earth, but ever wonder what happens when these stars die? What happens when a star, much like everything else in the universe, dies? This is a question that has fascinated astronomers and space enthusiasts for centuries. When a star exhausts its nuclear fuel, it doesn't just flicker out like a spent candle. No, it undergoes a dramatic transformation that can illuminate the cosmos with a dazzling display of cosmic power. The ultimate fate of a star, you see, is determined by its mass. Consider a low-mass star, perhaps like our own sun. When such a star depletes its nuclear fuel, it expands into a red giant, shedding its outer layers to form a planetary nebula. The core that remains is a white dwarf, a dense, hot remnant that will slowly cool and fade over billions of years. A quiet end, perhaps, but a beautiful one. But what about medium-mass stars? Those that are about 2 to 8 times the mass of our sun? Well, they have a more dramatic end. After swelling into a red giant, the core of such a star collapses under its own gravity, triggering a supernova explosion that can outshine an entire galaxy. The remnants of this explosion can form a neutron star, an incredibly dense object composed mainly of neutrons. And then we have the high-mass stars, the real cosmic giants. These stars, at least 8 times the mass of our sun, also end their lives in supernova explosions. Yet their cores collapse so much that they form black holes, objects so dense that not even light can escape their gravitational pull. So the death of a star is not an end, but a transformation. It's a process that can give birth to new stars, planets, and even life itself. It's a testament to the cyclical nature of the universe, where death is just another step in a never-ending journey. And there you have it, the cycle of life and death in the cosmos, from stars to black holes and back again.